So yesterday we were discussing about 2's complement representation. So we are seeing that for positive numbers we can represent the original form. That is, we can represent the number in the original form. And for negative numbers, we can use the 2's complement form of representation for representing the negative numbers. Okay. Now coming to range. Okay. So how to know the range of these 2's complement numbers? Okay. So let us see how to find out the range of this 2's complement form of representation. So let's say if we have n is equal to let's say n is equal to 3. Okay. So for n is equal to 3, first of all, let us write down the positive numbers. So for n is equal to 3, the positive numbers can be written from plus 0, 1, sorry, it is simple 0, 2, 3, 4, 5, 6 and 7. So it is nothing but triple 0, 0 1 0, 0 1 1 and 1 double 0, 1 0 1, 1 1 0 and 1 1 1. Okay, so these are my positive numbers. And coming to negative numbers, how to represent them in 2's complement form of representation? From minus 1 we are going to start. So minus 1 is nothing but 1 1 1, so 1 1 1, and minus 2 is nothing but 0 1 1 1 1 0, and minus 3, and if we see minus 3, it is nothing but 1 0 1, and minus 4, it is nothing but 0 0 1, and minus 5, it is nothing but 1 1 0, and minus 6, it is nothing but 0 1 0, and minus 7 is 1 0 0. Okay, so these are the negative numbers which are represented in 2's complement form, and this is the positive numbers which are represented in 2's complement form. Okay, so for positive numbers you are not going to apply any 2's complement form, and for negative numbers only we are going to apply the 2's complement form. Okay, now how to get the range of the 2's complement form of representation? Now what is the range of the 2's complement representation that we have seen yesterday? So that is what we have seen is different. Now how to get the 2's complement range? Now if you observe carefully, here up to 4, this is 100. Okay, so here if we can see the value of minus 4 which is represented in 2's complement form is 100, and if we go to 5, that is minus 5, the 2's complement form of minus 5 is becoming 011. Okay, so is if you see this 011, whether can you say it is 3, or whether you can say it is minus 5? What you can able to give the answer, whether it is 3 or whether it is minus 5? Can you able to give the answer? So for the 011, there are two equivalents. Am I right or wrong? Yes or no? Please let me know in the chat box. Can you able to see this 011, and here also we are having this 011. Okay, and 010, and we are having the 010. Okay, and 001, and we are having 001. Okay, so we are not going to consider these numbers. Okay, we are not going to consider this numbers. Okay, and here also on the positive side, if you see, we have 101, 110 and 111. Okay, so these numbers are also conflicting with this particular range of numbers. Okay, so that's why we are not going to consider them. So if we want to write down the range is from minus 2 power n minus 1 to minus 2 power, sorry, minus 2 power n, minus 2 power n 2 power n minus 1, minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. So this is the range of the 2's complement form of representation. Now let us try to discuss one more concept using 1's complement form of representation. Okay, so let us try to discuss this addition using 1's complement form of representation. So how to perform addition using 1's complement form of representation is we have some set of rules that we are going to follow. So let's say if we want to perform plus 5 minus 3. Okay, now you can write down the positive numbers as it is. Okay, this original number, you are not going to perform any complement on the positive numbers, and for negative numbers you are going to perform 1's complement. Okay, so on the negative numbers you are going to perform the 1's complement, and for the positive numbers you are not going to perform any 1's complement. Okay, so that means what will it happen? So that is nothing but, so this is nothing but 5 plus 1's complement of 3. Okay, so if I want to write this down, so what I can write is 101, and 3 is nothing but 0 double 1. If I perform 1's complement, then I am going to get 0 0 1. Okay, so if I'm going to add this is 1 0 1 1 is 0, and we are getting a carry 1. Okay, so 1 0 1 1 0, and the carry is 1. So in the case of 1's complement addition, if we are going to get a carry, we are what we should do? Any idea? So if we are getting a carry, first of all tell me, anyone had any idea if we are getting a carry, whether the result it is positive or whether it is negative? If we are getting a carry in 1's complement form of representation, whether the result it is a positive number or it is a negative number? Any idea, anyone? Any guess? So here in the 1's complement addition, if we are getting a carry, then the number is positive. If we are getting a carry in 1's complement form of representation, then the number is positive, and the carry should be added with the resultant. Okay, and in the 1's complement addition, if we are not getting the carry, if we are not getting the carry, then the result is, then the number is negative, then the result is negative. Here the result is negative. Okay, and what we should do? So we should again perform 1's complement for getting our result. Again perform 1's complement. 1's complement on the result. So this is a procedure we are going to follow. Now, are we getting a carry in this particular example? Yes, we are getting a carry. So what we should do with this carry? So we are going to add it with the resultant. So that means 1101 1 0. So this is our final answer, which is nothing but plus 2. Is it clear for everyone? Yes or no? Please let me know in the chat box. Exactly. So this is how we are going to perform 1's complement addition. Now let's see one more case. So let's say if we have minus 3 plus 2. If I want to perform minus 3 plus 2, how I am going to perform this addition? So let's see this example. How I am going to write minus 3. So 3 is nothing but 0 double 1, and I want to perform 1's complement on this. So that will become 1 0 0. Okay, that is nothing but 1 double 0. Now, and plus 2 is nothing but 0 1 0. Plus 2 is nothing but 0 1 0. I am going to add this to 1 double 0 and 0 1 0. Okay, so that is nothing but 0 and 1 and 1. So so did I get any carry here? No, I'm not getting any carry in this particular case. Okay, so what I'm going to do, I will declare this as negative number. Negative, since no carry. Okay, so if it is a negative number and there is no carry, then what we are going to do, we are again going to perform 1's complement on the resultant to find the result, exact result. So what I am going to do, I am going to perform 1's complement on this. That is nothing but it is 0 0 1, and the final answer is minus 1. Okay, so this is how I am going to perform 1's complement form of addition. Okay, now so try this one. Try doing this minus 5 plus 3 using 1's complement form of representation. You can take 1 minute of time, it's not a big deal. So please try and tell me what is the procedure you have followed. Okay, minus 5 plus 3. So we will simply get minus 2, and in this we are not going to get any carry. No carry we are getting, and on the resultant we are going to perform 1's complement. Okay, so this is how we are going to perform 1's complement addition. Okay, now coming to next type of addition, we have 2's complement addition. Okay, so let's see 2's complement addition. Now how to perform 2's complement addition? Again simple. So if I want to perform plus 5 and minus 3, okay, so on the negative number I am going to perform the 2's complement. Okay, on the negative number I am going to perform the 2's complement. So let's say plus 5 is nothing but 101, and 3 is nothing but 011. I am going to perform 2's complement on this 3, that is nothing but 1 0 1. Okay, now I'm going to add this. So 1 1 0 1 1 1 1 and 1 1 0 1. Now, so I'm getting a carry. So in the case of 2's complement form of representation also, if I'm getting a carry, then the final result is a positive number. Okay. So in 2's complement addition, in 2's complement addition, if I'm getting carry, if carry, then my number is positive and you can discard the carry. Okay. Discard, you are not going to do anything, you will just discard the carry. Okay, and if you are not getting any carry, if no carry, then the number is negative. Okay, if you are getting a carry, then the number is positive and you can just discard the carry. And but if you are not getting any carry, then the number is negative. Okay, so here in this particular case we are getting the carry. In the 2's complement form of addition, we are just going to discard the carry. Okay, and just the result is 0 1 0, that is plus 2. Whereas in the case of let's say if we have minus 3 plus 5, minus 3, sorry, both are same, but minus 5 plus 3. Let's see this. So in the case of minus 5 plus 3, so minus 5 is nothing but 1 1 0 and plus 3 is nothing but 0 1 1. So 1 1 0 1 triple 1 1. We are not getting any carry. So that is our resultant is a negative number. So we are going to perform 2's complement on the resultant. Okay. So perform 2's complement on resultant. And the number is negative and the result is negative. Okay. So what is the result we are getting? 0 1 0. That is nothing but minus 2. The answer is minus 2. Okay. Is this clear for everyone? Yes or no in the chat box, please? The 2's complement form of addition, is it clear for everyone? So after this we have BCD form of representation, or you can say 8421 code. So basically this BCD form of representation, it is a type of binary code which is used to represent a given decimal number in its equivalent binary form. Okay. So the BCD equivalent of a decimal number is written by replacing each decimal digit in its integer and fractional. Okay. We are going to replace each and every digit with its binary equivalent. Okay. So I will write down here. So in the case of BCD representation, okay. So for example, if we have a BCD number from 0 to 9, if we see, so from 0 0 0 and we will get up to from 0 to 8 if we see, or 9 if we see, we will get 1001. Okay, and this is 1300. Okay, so this, now what is the BCD code for 10? Can anyone tell me what is the BCD equivalent of number digit 10? Anyone here has the answer 1010 with you? Anyone has the answer 1010 with you? Okay, please don't do this mistake. So 10 is not 1010. 1010 is a normal binary representation. If you want to represent this decimal number in BCD, then you need to represent each and every digit with its binary equivalent. Okay, so that is nothing but 001 and 0000. Okay, for 11 it is 0001 0001. Okay, so this is how you are going to represent your BCD numbers. Okay, now in this BCD we have something which is known as BCD addition. So let's say if I want to add 5 and 3. Okay, so how I'm going to add 5 and 3? 5 is nothing but 100, sorry, 0101 and 3 is nothing but 0011. Okay, so the result is 1 1. So the result is simply 8. Okay, but what if I have 5 plus 5? Then can anyone tell me what is the answer you're getting? What is the result we are going to get here if we are going to add 5 and 5? Exactly. If greater than 9, we are going to add 6 to the result, not 1010. Because 1010 is not at all a BCD code. So there is no BCD code like 1010. Okay. So we have only 0 to 9 BCD codes are present for 0 to 9. Now, why we are going to add plus 6? Is there any reason behind that? What is the reason we are going to add plus 6 if the result is greater than 9? Is there any reason behind that, or just like that? Valid states are from 0 to 9 means 10, na? That number is 10. Then why we are adding 6? Exactly. 10 to 15 are invalid. That is, total we have 6 invalid states. Okay. So total we have 6 invalid states. So for skipping the 6 invalid states, we are going to add plus 6. Okay. If result is greater than 9, then we are going to add plus 6 to the result. Okay. Then we are going to add plus 6 to the result for making our result to a valid BCD code. Okay. So this is how we are going to perform BCD addition. Okay. Is this clear for